crash. I don't know. We always have problems with the male section. The problem we are running a little bit late, especially for male. I think for female, because we didn't have the this 1 day off because of vacation and oh sorry, because of the was it the national day? No, it was the sport day. Yeah. Anyway, so you can see the screen, right? Do you see the screen?
Yes, Doctor, now we see it.
Okay, that's good. Thank you. So I think we stopped here. So last time I will repeat what I've said. Last time we covered the entity, the architecture, how to write it. We talked about library as well, that you need to include the library. We gave you an example of an AND gate, and we start talking again about some types, data types. And we told you that the most important type is the STD logic, which models very well a pin or a wire in a real circuit, because this is what we will be doing. It's like a wire inside FPGA. So STD logic is the best one. And then we told you as well, if we have STD logic will be used for one line, 0 or 1. But if we have more than that, for example, the address bus, as the example that we gave you for the ROM. So let's say we have 4 lines here. This A needs then to be declared as STD logic vector, and you specify how many lines. So you say 3 down to 0 for this case, if we have 4, right? So do you still hear me? Yeah.
Yes.
Okay. Thank you. Okay, and then we stopped here. I think we gave you this example, this small exercise, and we just want the entity. Of course, we didn't ask you to do the architecture. I will show you in the next lecture how to write an architecture, for example, for a multiplexer, because there are some statements that you need to learn for you to be able to use it, to implement it. But this one is just about the entity. You know the normal multiplexer. If you have 4 lines here, you have 2 control lines. We have 1 output. This is 4-to-1 multiplexer, right? Those 2 lines, they are together. I mean 0, 0. If it's 0, 0, we get this line, first line out. If it's 0, 1, 1, 0, 1, 1. So when we declare this in VHDL, it's basically one line of, one bus of 2 lines. So we put it as 2, and this is S, select line or select or whatever. You can give any name you want. So this is 2 lines. So basically we use STD logic vector for this one. Now those lines, those individual lines, which we call them individual lines of the multiplexer, those themselves could be buses. So it doesn't need to be just one line. So I can have here 4. Each one is 4. Of course, they need to be of the same size. So I can have A, B, C, D, and this one, the output O. This should be 4 as well. So if we select 0, 0, all those 4 lines will go to this line. So if A is a 4-bit number, O will be the value of O will be equal to the value of A. If we put 0, 0, if we put 0, 1, then the output of O will be equal to B. It's the normal multiplexer, but instead of having only one line, each individual input is basically a bus. Okay, so then this is the question. So how many inputs do you see here in this multiplexer that we want to do? How many inputs do you see? Do you hear me? Are you still here?
Yes, Doctor.
Okay, how many inputs do you see?
1.
1 input. Oh.
2 inputs.
What are the 2 inputs?
The 2 select inputs.
This is just 1 input. This is not 2 inputs. Just one input called select. The size of this input is 2. So this is when we declare it.
It's 5 inputs.
When we go for port, we put port. So we need to put select as one of the inputs, and then this is input, and then std logic vector 1 down to 0. So this is one input. It's
So the
one
total
input.
is 5 inputs.
We have 5. So good. So we have D0, D1, D2, D3. They are all inputs. They are all of the same size, 8, and they are same type. So I can put them together, D0, D1, D2, D3, and then input, and then std logic vector, and then I can put 7 down to 0 here. How many outputs do we have?
One output.
One output, which is this D out. You can call it D or whatever, or D out, and then it's the same type. It's out here, and then the rest is the same type. D out, and then of course we close the parentheses and we put the semicolon. This is how we do the entity for this one, which is here in this slide. Of course, I put them here separately, D0, D1, D2. You can have them all together in one line. You don't need to separate them, but of course both are correct. Is this clear? So
Doctor,
if it was a simple multiplexer with just one line, so select. If those are single lines, then it's exactly the same declaration, but we don't have std logic. It's not vector, it's just one line, it's std logic, and the rest is the same. The select is 1, so this is for this one. If it was simple line, yes.
do we use 0 to 7 or 7 down to 0, or both of them would work?
Both of them are correct, but in the software tool that you use, if you use schematic with it, it's better to use 7 down to 0. Use down to 0, just to make sure that otherwise the software, this is related to the software that you will be using, yeah. So always try to use down to 0 instead of 0 to 7.
Thank you.
If you have just pure VHDL, it will work with any. But if you mix, because in the schematic apparently they declare them as, you know, down to 0, they use down to, so better to stick to one name. Right, now I will move to some conventions in naming and labeling. So we start with naming and labeling. I think I got this question before about, you know, is it case sensitive or not? So VHDL is not case sensitive. You use uppercase or lowercase is the same, so be careful. So if you declare a variable like this, or a port, for example, you use A, and then you use A later, they are the same. They are not different. This A or this, they are exactly the same. So basically you cannot use this for a port and you use this A as well for something else. You cannot do that. So it is not case sensitive. It's not like C++ or C. Names. Rules that you need to follow when you use names. Otherwise, if you don't follow these rules, you will get errors, syntax errors. So with names, we can use the alphabet characters, A to Z, lowercase or uppercase. You can use numbers as well, digits from 0 to 9 in the names. And you can use underscores. So those are the allowed characters that you can use in a name. So basically you cannot use this type of characters. Is this clear? So do not use 2 or more consecutive underscore characters. So 2 after the other. So for example, you use A, an underscore, and then followed by an underscore, and then you use 2. This is wrong. So those are 2 consecutive underscores. You can do this, A to B. This is fine, because those 2 underscores are separated with another character. This is fine. There is, I think, something that we said do not underscore a name a name should start with an alphabet character. You cannot start with a number. So basically, for example, this 2_a is wrong. And you will get syntax errors because it starts with a number. Is this clear? So those are rules that you need to follow. Of course, the last one, it says all names and labels in a given entity and architecture must be unique. So basically, when you use A for an input, then that's it. You cannot use this A again inside your architecture for something else. You cannot use it, for example, for a variable or a constant or whatever. So it's reserved for now, it's for this input, then that's it. It must be unique. You cannot duplicate the names. Comments are very important. You know, when you write, when you work in a company or when you write a code, even for yourself, you know, for designers, usually they write very long lines of code, you know, thousands of lines. And even for you, if you leave your code for, let's say, 1 week, 2 weeks, and you go back to it, you will find it very difficult to understand what you have written if you do not put comments. So always try to put comments. Comments are for you and for someone who's going to read your code to understand it quickly. How do we use comments in VHDL? Is we just use this double dash. So you can put it anywhere in the line. So you can start with a double dash. So this is a comment. So we started with a comment. So what follows this double dash is all a comment until we press enter. Once we go to a new line, then that's it. It's the end of the comment. I can start in the middle of a line. So I can have a statement like this, and then I will start my comment here. And then when I press enter, then that's it. End of the comment is here. Now I can start another line. So if I want a comment to be in multiple lines, I need to start all the lines with comments. So with the double dash. So this is a comment that is in 2 lines. Right. Of course, all the words that you've seen in red in this presentation are reserved words. You cannot use them as names for your or identifiers for your ports or variables or whatever. So you cannot use them. Those are already reserved. I put here some as well, but those are not all. And the good thing, you know, when you work with a compiler or the software tool, when you write code, it will always highlight those reserved words. When you write the text, you can even change the color. You can go to the settings and the font, and you can change even the colors for those. So you can see it in red, or you can see it bold, or whatever. So it's clear that it's a reserved word. Even if you try to use it, you don't know if it is a reserved word. You will see it that it will be highlighted as a reserved word. VHDL is a free format language. So basically, what we write in VHDL, we start a statement and then we end with a semicolon. Now, how to write this statement? You leave spaces, you don't leave spaces, you go to new lines. For example, I start the statement and then I will continue in the next line and then I will put the semicolon here. Or you start the statement and then you leave space, you continue here, you leave space, and then you put the semicolon. They are all the same. It doesn't matter how do you write it. As long as you start the statement, you end with a semicolon. This is what the compiler will see. The beginning of the statement until the end of the comment. Sorry, the semicolon. Then it's the end of the statement. How did you write it? For example, here, if I write an if statement, I can write it this way. I can leave spaces here, or I can have it in 2 lines. They are all fine, all correct. But of course, you need to select the best option. I mean, to make your code clear and easy for someone to understand it. So there is no need to leave spaces. There is no need to write it in 2 lines. So this is the best one. Although they are all correct. I mean, all of them will not generate any syntax error. Is this clear? Can you still hear me? Yeah?
Yes, I can hear you.
Okay, good. This is a small exercise just to find the errors here in this code. I think the solution is already in the next slide. As you can see here, this is a continuation of the previous comment of the previous line. So we should have double dash here, or this can go to the same line. Otherwise, this will generate an error. What is OR gate? I mean, this is an error. We have here as well a name that starts with 2, so which is the same mistake here. This is the name for the entity. Yeah, we need to change it in both. Here we should have AND keyword and the name of the entity and semicolon. So we need to AND the entity with the AND keyword.
I think
that's
also
it.
for C, doctor, there is no semicolon for the last point.
Which one? Yes.
For
Good.
the point at the end,
Yeah.
there is no semicolon.
There should be no semicolon here. We said the last statement, we just close the parentheses and then we put the semicolon after that. So this is again the problem. Is this clear? So those are some syntax errors. So if you write this code, you will get all the syntax errors in your code. Okay, so this is for this question. I think the answer is already here. How operators. I think I already used some operators, and I told you we will talk with more details about operators. So you've seen this one. We used it. We use this one as well. We use as well the AND or operator. So we have different classes or different groups of operators. We have the logical operators. I think those are easy. So we used AND. We used OR. So we have others. So we have NAND, we have NOR, we have XOR, we have XNOR. We have NOT as well, which I didn't put here. So it's not. You can just put NOT. We have the relationship operators. And usually we use those in if statements to compare. So this one, if I want to compare if it's equal, this is what I use. If A, for example, equal B. And then we have not equal, we have less or equal, we have more or greater than, and we have greater than or equal. I think you know this. We use although probably it's a little bit different in C++, for example, in C++ or C. For equal, we use 2 consecutive equal, right? And equal on its own, we use it to assign for assignment. There is a little bit different, but yeah, you understand the use of them, right? Now this one, those 2 operators, they are both for assignment. But which one to use? I think you need to be careful with this, and you need to know exactly which one to use. Right. So if I use, for example, this, I do A is equal B. I'm using this operator. This means that this A is either a signal or an output port. So if I have a port in my entity A, or if this one is declared as a signal, I can use this operator with it if I want to assign something to it. So if I want to assign B to it, then I need to use this operator. Now, where do I need to use the other one? A is equal B, for example. In this case, this A must be a variable. If you declare A as a variable and you want to assign something to it, this is what you use, this operator. If you remember as well, we use this operator during assignments for constant, when we assign a value to a constant, when you assign a value to an initial value to a variable, and even when we assign an initial value to a signal. So during the declaration and initialization, we use this one as well. So this is when you use them inside the architecture. Now, when you declare constant, for example, a, and then type, if we do bit, and then we use equal, and we put a value. We did the same for variable, and the same for signal. So we, during the declaration, we use this operator. I don't use the other one. Is this clear? So this is the difference between the two when we use the first one and when we use the second one. So if you declare a variable x, and then inside the architecture you put x equal, you use this one where x is a variable, you will get an error. This is wrong. You will get syntax error that tells you that you cannot use this operator. Right. So those are for the assignment. Now we have as well what we call the shift operators. And shift are used to shift bits. So if you have 10 bits or 8 bits, we use them to move the position of the bit, to change the order of the bit. And I think this one probably you didn't see them in other languages. So I will show you examples later on in the next slide for each one. We have logical shift and we have arithmetic shift. There is a difference between the two, a small difference. We can shift left, we can shift right. So we have, and then we have rotation as well. We can rotate left or we can rotate right. For rotate, it's just logical. We don't have arithmetic rotate. So I will show you examples later on how to use those operators. And then we have the multiplying operators. We have the normal multiplication. We have the division. And we have the modulus, like the in C, and we have the remainder as well here. I don't want to waste time explaining the difference between those two. I put a, because it's not really very important for our case, but I put a video, YouTube video on Blackboard, so you can watch it and see the difference between them, between modulus and remainder. And then we have the addition operators. We have the normal addition. We have the subtraction. And then we have the concatenation. This is something new as well that you don't know. So I will explain it in the next slide with an example. So we have concatenation. We call it the concatenation operator. So I'll explain what is concatenation with an example. So now I'm going to show you some examples for shift operators and the concatenation. I started with AND as well, just to show you if we have more than 1 bit. You know that if I have A is 1 bit, we put 0, and B is 1. When we do C is equal A and B, so what should be the value of C? If A is 0 and B is 1, C, you will get it equal to 0, right? Now, of course, I can do this AND if I have multiple lines as well. So for example, if A here is 4 bit, this is 4 bit. Remember, we use double quotes when we have more than 1 bit. If we have 1 bit, we use single quote. So A is 4 bit, B is 4 bit as well. Now, if value should be 4 bit as well. When we do value is equal A and B. So what should be if A has this initial value 1, 1, 0, 0, and B has this initial value 1, 1, 0, when we do an AND, we do bit by bit. So we get 0 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1, 1 and 1 is 1. So the result should be this one. So this is what we should get in value, right? So I can do AND with just a single bit, or I can do AND with multiple bits, 4, 8, 16, or whatever, right? And this is what will happen. It goes bit by bit, first bit with the first bit, second bit with second bit, and so on. Is this clear? This is for AND. Now, concatenation. Concatenation is basically putting the bits together. And by the way, we call those operators like bit manipulation. We are manipulating bits. We are changing the position of the bits or placing bits in different positions. So if I do value is equal A concatenated with B, this is how I write it. So basically I will take the value of A. So this is A, and the value of B. They will be placed next to each other, and this will form the new value. So this is value. So value is an 8-bit in this case. So if I'm concatenating two 4-bit values, then the result is an 8-bit value. If I'm concatenating two 8-bit values, then the result is 16-bit. The values put together, the two values together. Is this clear? I think concatenation is very simple. We are just putting the bits together. We are not adding, we are just placing the bits together. Is this clear? So this is for concatenation. Now I will move to shift. Shift operator is basically shifting the position of the bit by, you can shift by 1 position, by 2, by 3, and you specify here by how many positions you shift. So here, for example, in this example, I'm saying shift by 2 positions. If I'm doing A concatenated with B, so I will take the value of A concatenated with B. What was the value of A concatenated with B is here. And then I want to shift it 2. Do you hear me? Yeah? You still hear me? Hello?
Yes, we can hear you, doctor.
Okay. So we here shift logical. So what we want to do is a logical shift left. So we want to shift left by 2 positions. So this, what does it mean? So now what will happen? So we have 8-bit. We start with 8-bit, and the result should be 8-bit as well. So this is those are the values that I have. We want to shift left. So which means I shift this position like this. We shift this direction. So if I ask you to shift those bits by 2 positions, what do you think will happen? So we and those are our borders. So we have 8 bits. We shift by 2 positions. What will happen? So we'll have the 2 bits out, right?
Yes, I got 0, 0, 1, 1,
So
1, 0.
those 2 bits will be out. So we will have 2 positions empty from the beginning, and then the rest. This is what will happen, right? So we shift those, the last 2 bits will go out, because remember the result will stay always 8-bit. We started with 8 bits, it stays 8-bit. We are shifting those 8-bit. And then those empty positions will be filled with zeros. And this is what we get as a result when we shift logical left. Is this clear? Now, if I want to shift right, we shift logical right. So we shift the other direction. Now I'm going to write them again, the values. So this is the value 0, 1, 1, 1, 0, 0, 1, 1. Now we want to shift the other direction. And the question here is to shift by 3 positions. The previous example, we shifted by 2 positions. We can here we shift by 3 positions. So what will happen? Again, so we shift, we will have 3 empty positions, right? And then those 3 will go out, and then we'll have the remaining values, right? And then we put zeros here. This is what will happen, and this will be the result. And this is what I put here. Is this clear?
So,
Right, now I'm going to move to shift, to rotation first. Rotation, rotate left. I can rotate left, I can rotate right. Now, what's the difference between rotate and shift? Rotate, we don't lose the bits. So the bit stays, it's just we rotate them. So they stay here. So the bit that goes out from here will come to this position. Is this clear? So we are not losing bits, we are just rotating them. The shift, we lose bits and we put zeros in those positions. Do you guess the point? Yeah. So if I put here the value again, we start with this value 0 1 1 1 0 0 1 1. Rotate by 2 positions. I can rotate by 3, I can rotate by 4, it depends. Yeah. Now we said we want to rotate by 2 positions. What will happen? Rotate left, so we go like this. So the bits will be rotated by 2 positions. Can you see the answer, right? So if I rotate by 1 position, I will get this one here, and then 0 1 1 1 0 0 1. And then if I rotate another time by another position, so I will get 1 1 here, and then 0 1 1 1 0 0, which I get here as an answer. Is this clear?
Yes, doctor.
Yes or no?
Yes, yes.
It's just rotating the bit, just
Yeah.
moving them. Yeah. So when we rotate, this last bit will become the first one if I rotate only with 1. If I rotate on another time, so the next bit will be the first one, and so on. So we are shifting the bits. Again, it's like we are shifting, but we are not losing the bit. The bit that goes out will go to the other position. I'm not losing them. It's not like the normal shift. The normal shift, the bit that goes out, then that's it. They are lost. And you can apply the same for right shift, right rotation. You can rotate right and you can rotate left. I put an example with left, with 2 positions. You can rotate with 3, with 4, and so on. And the last one is the arithmetic shift. Basically, the left arithmetic shift is exactly the same as the logical shift. So when you shift logical left, or when you shift arithmetic left, you get exactly the same result. It's exactly the same operation. The difference is when you shift right arithmetic. So what will happen? I will explain to you why we have this difference. Now, if I have these are my starting points. And the last example is shift right by 3 positions. So we want to shift right. So basically we shift this direction. Right? So we shift right by 3 positions. What will happen? Those 3 bits will go out. And then we will have 1, 0, 0, 1, 1. And then we will have 3 positions here. Now, we don't fill with zeros. We can fill with zeros or with 1. It depends. It depends on the last bit here. If the last bit was 1, we fill with 1s. If the last bit was 0, we fill with zeros. So as for this example, the last bit here is 1, then we fill with 1s here. And the student, they do this mistake, they always fill with 1s. They think it's right, sorry, the right shift arithmetic, we fill always with 1. No, we don't fill always with 1. We fill with 1 if the last bit is 1, and we fill with zeros if the last bit was 0. Right. And just to let you know why, because in we didn't talk so far about negative numbers, you know. So far we talk about positive values, you know. Why I tell you what is 0 using 4 bits, this is 0. What is 1 using 4 bits, this is 1. What is 4 using 8, sorry, using 4 bits, this is 8, and so on. But what if I tell you what is minus 8? We didn't do this yet. We will do it in one of the lectures, the coming lectures. So you will see that for negative numbers in binary, the last bit is 1. If we are dealing with sign values, sign numbers, which means we can have positive and negative values, you will see that the last bit for all negative values is 1. So when we do a shift, an arithmetic shift, basically we want to keep this information, the sign. If the number is negative, I want to keep it negative. If the number is positive, I want to keep it positive. And by the way, the shift operator can be used as a simple division by 2. So let's give you an example. If I have this number, this one, I have 4 bits. If I ask you to shift, what is this 4 bit? What is this number in binary? What is this number in binary? All of you should answer the question immediately. What is this number in binary? 0010.
Is it 4?
Are you asking me or are you giving an answer?
I'm answering.
Yes, good. It is 4. And all of you should answer this. So this is 4. Now if I ask you to shift this direction by 1, what do we get? Shift left. It can be
8.
arithmetic or logical. So what do we get? We get 0, 0, 0, 1, right? So we get this 0 out, and this will be shifted by, so we get 8. So it's a multiplication by 2. If I shift the other direction, I will get 0. This is the value that I will get, right? 0, 1, 0, 0. This is 2. So it's a division by 2. So the shift operators can be used as a division or multiplication operation, dividing by 2. If you shift by 2 positions, you are dividing by 4. If you shift by 3 positions, you are dividing by 8, and so on. So you can always use those as an efficient and quick division or multiplication operation. So now if the number was negative, let's say that we are dealing with sign values. If we are dealing with sign, then this number will be considered as negative value because it has the minus. So if I do a shift, it has 1 here, sorry. So this is a negative value. If we do a shift arithmetic, we can keep this value, we can keep the 1. So even for the result will be negative as well. It will stay negative. We'll come back to this when we cover the negative values, but this is the main reason, just to keep the sign information. If you need to keep it.
Doctor,
Yes.
what about
Yes.
for the shift left arithmetic? We still use the left bit or we use the
Shift left, I told you it's exactly the same as the logical one. We fill with zeros. Shift left, it doesn't matter.
Oh.
It's the same. Shift left arithmetic or shift left logical, they are the same. The difference is the right, shift right, arithmetic and logical. So logical, we always fill with zeros, even if we do a logical shift. If we do an arithmetic shift, then this will depend on the last bit. Is this clear? So I think that's it for this one. I think we will. I will move on now to the next lecture, which is continuation of this one. We'll continue with VHDL.